Um, we have 100, and we need to think about the fact whether or not it starts at a maximum or minimum. Whether or not this value is positive or negative will determine whether it starts at a minimum. It starts at a minimum if it's negative. It'll start at a maximum if A is positive. So you'll always need to double check that now that we're getting to the last level of this modeling unit. You always need to think with A, am I starting at a maximum, which would make this positive, or a minimum, which would make A negative? Technically, the absolute value of A is your amplitude. So A would be then negative 100 because we're starting at a minimum. If you're talking about entering a Ferris wheel, you're starting at the minimum height, right? You enter on when it's at the bottom of the Ferris wheel. You don't enter at the top of the Ferris wheel. So you technically start at a minimum and then get to the maximum and then come down. So A is negative 100. We found that from saying, okay, it's half of the diameter. And then from there had to be negative because we're starting at a minimum. It says that the boarding platform at the lowest point of the Ferris wheel is 12 feet above the ground, which means you have to get on stairs in order to get to that platform in order to get onto the Ferris wheel, which we've all experienced. So we need to find the value of D. What that means now is that we've got this platform that's 12 feet tall, and our principal axis, right, is talking about going halfway up. And if our amplitude is 100, then our principal axis, that middle line, would just be those two together, right? The 12 feet added on extra to the 100 amplitude. And so we're not actually fluctuating between 0 and 200, right? You wouldn't scrape the bottom of the floor as the Ferris wheel goes around. You're actually fluctuating between 12 feet off the ground and 212 feet off the ground, that full diameter up, right? So D would be 100 plus 12. So D is equal to 112. And this one is positive because we're above ground, right? Our height is positive. So now it says calculate the number of minutes until a person riding the Rising Rad reaches the top of the wheel. So notice, separate question, separate from A and D, because you can get follow-through points here, right? So no matter whatever you put down for A and D, you have to put something down for A and D. You get follow-through points as long as you put them into the equation and find the maximum from that equation. So our equation is h of t equals negative 100 cosine of 36 times t minus 5. Notice it doesn't look like our normal BT, and that's why they didn't have you solve for the inside. They wanted it to be like this, and so they gave you the part that was tricky. And then if I go ahead and graph that and find the first maximum, I'm trying to find the time with my first maximum. You won't see it at first. Why? Because your window settings need to change. If we know, we'll leave our X values the same way it is now. We know that we're going from 12 feet to 212 feet. So I'll keep it -2 here, but I need to go to 220 up top to be able to encompass the whole thing. And here now we can see our fluctuation, and I don't need to change my X axis. Interesting. Okay. So what I did up above with A is correct. That sometimes you will be asked whether or not A should be negative or positive, or justify whether or not it should be negative or positive. And what we just did was correct. Now, they did something funky here where they did a horizontal shift, and they shifted it so that if you left A as positive, it would start at a minimum. They shifted it so this minimum that should have been here is now over by that much. So this is why it's really important is I thought it was one way and then I graphed it and notice I start at a maximum. So I technically was wrong up above, which happens all the time. My answer key said positive 100 and I thought my answer key must be wrong. I didn't account for the negative, and so that's why I paused and thought for a second back then. But now I'm looking and I'm like, oh, okay, no. The horizontal shift that they have going on in here has now changed that. So this actually should be 100. This is still true. We should still think about that, but always double check graph to see if it's true, because it's not. Negative 100 had me starting at a maximum, and I know it's supposed to start at a minimum. So I'm going to go back and delete the negative from in front of the 100 and graph it. And now it has me starting at a minimum, and now that's true. And now it says, calculate the number of minutes until a person riding the Reisenrad reaches the top of the wheel. They're probably only going one circuit, right? One routine. So we're looking for when do they reach the maximum? So I need to find that maximum point. And the point is 5 to 12. Go ahead and tell me from there, how many minutes will it take for them to reach the maximum? Remember that when you grab these values from the point, from the coordinate, you need to remember which one of the coordinates, which one of the values is the answer. If we're asking for the time, this guy is time. This guy is height. So we're looking at 5 minutes. Stop. Take a second. Does that make sense that it takes you 5 minutes to reach the top of a Ferris wheel? Yeah, that makes sense that it would take me 5 minutes to reach the top of a Ferris wheel. Calculate the time required to complete one rotation. Now, this is the period, right? We can tell from the context of the situation. We could grab it from our equation, but it looks different than we're used to. So what we're going to do instead is grab it from our graph, because we've already graphed it. So I know that my minimum starts at 0. I'm going to find the next minimum and figure out how long it took me to get from that. Oops, I don't think I went over far enough. There we go. So it goes from 0 to 10 is for my minimum, which makes sense that from 0 to 5 was my maximum. So then double that to get to my next minimum. So my entire period is 10 minutes. So you could have either doubled it from above or found it in your graph. Either way, whichever one first makes sense to you. Both would work. Okay, determine a reasonable domain and range for this function. So we need to keep in mind, first of all, our range is pretty easy, right? We know that we're between 12 and 212. We've already talked about that. So let's do range just right away. Range is, and you need to remember to include the variable that you're using to represent your output, which in this case is h, such that h lives between 12 and 212. So that's our reasonable range. Domain, we need to think about the context, always thinking about the context. And the context of this is, and think about the story that they just told you with the 2 problems above, how many rotations are we doing if we go on a Ferris wheel? Probably only 1. Are there some Ferris wheels that you do 2 rotations? Absolutely. But a reasonable domain here, and look at the story that it has you answering above or previously, how long does it take to complete 1 rotation? Okay, so then what would be a reasonable domain? Well, probably only 1 rotation is what we're doing. So from 0 to 10, how long it takes us to complete 1 rotation. So that's why, it's telling you a story as you go through. Okay, in 1 10-minute ride, hey, continuing that story, during what interval of time will a person on the Reisenrad be at least 100 feet above the ground? Now that is h, right? In other words, our output. So setting it equal to 100 and seeing, hey, when is it above 100? We would be looking at our graph, at graphing a second equation. y equals 100. Between 0 and 10, so we're really only looking at here and here. And it says during what interval of time. So we're just figuring out at time here to time there is when it will be above ground. So from t equals what to t equals what will this guy be above 100 feet? Okay, all you have to do is find the intersection, right? And we're looking at the t values, so we're only looking at our x quote unquote values. Of those coordinates. And the x value is 2.31, 3 sig figs, to 7.69. So from 2.31 minutes to 7.69 minutes, you will be above 100 feet in the air. It says comment on the reasonableness of this model. And so when it asks about reasonableness of models, what the IB wants you to do is poke holes at this. If they say comment on the reasonableness of this model, it means that there's probably something unreasonable about this model. And so think about, first of all, the shape. Is the shape representing the general idea? And the answer is yes. The shape of this model represents the idea of this. Context, though, what happens on Ferris wheels? Well, you get on the Ferris wheel, you go for a little bit, and then you stop and wait for somebody else to get on, and then you go for a little bit and you stop. So does it actually take 10 minutes to complete? If you were just going around consistently, maybe then it takes 10 minutes. But we haven't talked at all in this model about the fact that Ferris wheels stop, and that hasn't been discussed at all. So this is what I wrote for the reasonableness of this model. And it talks about this is like the general shape of what happens when we go around a wheel, but we have not taken in consideration the realistic aspect of the time on Ferris wheels. And so that's what you would need to talk about in order to get this final point. Okay, that is it for you today. This was a long one. Sorry about that. Good job.